Okay, so in the last videos, a couple of videos, we saw that the Finch has sensors that we can certainly use, and we also looked at how exactly those sensors respond. So we did a little bit of research into the values that the sensors send back to the code. And so what we'd like to do now is let's do a little project to show you how to wrap all this together, maybe in obstacle avoidance. And what I mean by that is, let's just say that our assignment then is to have the Finch move towards this block here. But we like it to stop some safe distance in front of the block, maybe say about that far. Maybe we'll have it roll up to here and just sort of stop, and always do that in sort of a safe way, so we don't want the Finch crashing into the thing and getting too close. So that's our assignment. We like the Finch to roll and stop when it gets a safe distance in front of the block. Okay, so how are we going to do that? Well, here's what we can do. I'll just get started with a green flag here, and what I'll do is get the Finch moving. And we'll get a good clip going, maybe 30 and 30. Okay, get it moving forward there with some decent power. And what we'll do is to allow it to sort of move for a bit. I'll go to the control here and I'll just wait. And I'm sort of looking at, I don't know, if I started out maybe alligator 1, 2, maybe about 3 seconds or so. I'll sort of wait for 3 seconds to allow the Finch to roll. And then what I'll do is I will stop it. Okay, so this is about it. Let's see what happens. So I'll hit to click my green flag, off we go. 2, 3. Okay, not bad. A little closer than I'd like for safety, so maybe I'll change the 3 to a 2 like that and back it up. Try to run it again, see what happens. Yeah, a little far this time, so maybe the 2 to the 2.5. And I promise this is making my point for me here. Here we go, let's run it again. Okay, not bad. That's about what I'd like, okay? So I know that if I sort of come back here and let the Finch run forward at a power of 30 and 30 for 2.5 seconds, then I can get a pretty safe stopping distance in front of a block, okay? But here's what can happen. Suppose that the next person comes in and says, oh, okay, and starts the Finch right there. Okay, what's going to happen now? If I run it, crashes into the block, and the motors are still running, and the poor Finch is struggling. Likewise, if I back the Finch all the way up here, maybe there's a really huge distance between the block and the Finch, depending on the environment, and off it goes. You know, this is too wide of a gap here. I'm not sort of meeting the spec that I'd want. So it turns out that the problem really isn't the environment, is really tough to deal with over here for the Finch, because so many different things could happen. The Finch could be here, it could be back here, it could be here, the block could be at an angle. I mean, there's all kinds of scenarios. So we need something a little more, say, intelligent in our code, other than just waiting for 2.5 seconds. So what we can do instead, let's break this apart. And it's certainly okay to get the Finch going at the speed it was, but let's tap into these sensors that we have available here. So what we'll do is we'll instead go to control over here, and let's, instead of just waiting for 2.5 seconds, let's wait until something happens. And what is that going to happen? What can happen? Well, why don't we wait for this right obstacle to become true? So in other words, start moving, and don't just wait sort of blindly 2.5 seconds. Let's wait until the obstacle sensor says, hey, there's something in the way, and only then would we remove power to the Finch. Okay, so let's see what happens now. So a little modification there. Let me just run it again. Here goes the Finch. See, it stopped. Pretty nice distance in there. Everyone's safe. If the Finch is too close like this and I run it now, so I promise I'm clicking on that green flag, but it's not moving. Well, it's inching forward a bit, but you can see that it's applying the power, but then right away it detects the obstacle and stops right away. So see, the Finch just kind of doesn't want to go. And see, the behavior has really changed versus when it's back here. Back here, it's always ready to go. Always ready to go, here it goes, and it stops. But if you get it too close, of course, it just doesn't start rolling. And this is what we mean by making your Finch a little more intelligent relative to the environment around it. It's now responding to the fact that it's sometimes safe and not safe to go. And so remember, even when I made the distance as large as possible between the Finch here and the block, it stopped with too much of a gap in between. But now that I'm using the sensor, it should always sort of maintain that good stopping distance, like right in here, nice and safe in there. So see, that's what these sensors allow us to do then. And that's how you sort of integrate them into your code. So in the next video, I'll show you then, that's obstacle sensing. I'll go on to the light sensor, but let's make a little bit of modification here before I do that. Of course, I have these two sensors, so maybe I might want to see if either one of them gets triggered to even give myself a little bit of a more robust stopping condition in there. And so let me drag this out, and I just want to encourage you then to look at the operator blocks And you see that we have this and in the or in there. And so and or is like searching for a library book where you want an author and some title, or an author or some title, something like that, depending on what you're searching for. So let's do the and, I guess, here to make it a sort of a really strict search. We'll say, hey, turn those motors on, but wait until I see both the right optical sensor and the left optical sensor both triggered at the same time. And so you can sort of see what the code looks like now. So it's just a little bit of a modification in there, but you can see what the result is there, is that I'll just keep the motor powered until both of these sensors are registering that something is in the way. So I don't think we'll see much of behavioral difference, but it's in the Finch, but let's just see what happens. So here it goes. All right, yeah, pretty similar in terms of what we see, but we have a little bit more stricter condition for stopping there. Okay, so in the next video we'll do a similar project, but we'll use the light sensor.